Okay, so welcome today. We're going to be starting chapter 2 today. Chapter 2 is all going to be about inequalities. This does one of two things. Introduces a new topic for the new chapter, inequalities, because they're going to have greater than or less than signs. It also gives a chance to slightly review a lot of chapter 1 and what we may or may not have fully had a chance to grasp. You'll notice a couple different things. You'll notice that the board is just this one board where I was filming both boards. Because this is after school that I'm filming and not during class, I don't need to work through both boards because you're not going to be having to worry about copying down what's here when I move over there. So I decided to zoom the camera in a little bit closer. That will also address those of you who are trying to read what's going in on this video. I'm going to do my best to try and make this work. Again, I'm going to repeat this pretty much exactly like we did in class, so that if you are absent, the whole point of this is to make sure you're caught up. You'll hear what we said, how we said it, how we went over everything, and it'll keep you up to snuff. But let's go ahead and get started. All my stuff was out of shot there. Chapter 2 is starting out with writing and graphing inequalities. So we have 2.1, writing and graphing inequalities. You may notice some noise in the background. Again, realize that maintenance is going around cleaning up the other classrooms. So if there is noise, that's usually because they dip their head in, they're like, oh, he's doing something, and then they'll leave. So if there's any sort of disturbance in the background. So first off, inequalities, unlike equations, inequalities on equations have many solutions that are shown to be part of a set or on a number line is typically how we show them. So they're solved the same as with equations, but they have one additional step. Like I said, the good and the bad thing about chapter 2 is it does directly stem from chapter 1. So if you weren't too sure on a lot of the rules on how we're solving equations, this is a good chance to kind of get your review. If you're already solid on this, you can just focus on, it's a pretty easy chapter if you're solid with the equations. So it'll give you a chance to kind of sit back and relax. Okay. They are solved the same as equations, but have one additional step. Okay, awesome. So what is that one additional step? Before we do that, let's talk about what the inequalities are demonstrating. What about them? Why are we going to be going into this additional step? So if we pick two random numbers, the numbers that I had up here, we had 6 and 8. So let's put 6 and 8. Let's actually get a new black marker for this. There's a trash can somewhere back there, so if you see me fling it off stage, hopefully it made it. Okay, so I have 6 and 8. Okay, so which one's bigger? Is it going to be 6 or is it going to be 8? Well, we know 8 is going to be bigger, so I'm going to open my inequality symbol in that direction, which opens our first line of topic, or first line of talking. These symbols right here are our inequality symbols. If you need me to separate them, I have 4. I have the first, the second, the third, and the fourth symbol. These are our 4 inequality symbols. And I like to ask the class, I'm like, hey, which one is the greater than symbol? Most of them are going to point out 2. Some of them are going to point out 1. Some of them are going to point out both of them. But most of the students are going to point out 2. Somebody who's like really thinking ahead, they're like, hold on, this sounds like a trick question. 2 and 4. And you're kind of right. The answer is none of these are technically greater than symbols because an inequality can be read in either direction. Because if I look at this, 8 is in fact greater than 6. But Mr. Johnson, that's a less than symbol. Yeah, because 6 is less than 8. The symbols themselves are called inequalities because they can be read in either direction. So both of these can be read as either greater than or less than, greater than or equal to, or less than or equal to if they have the bar beneath it. Doesn't matter which direction we're reading because it can mean, or it does actually matter which direction we're reading because it can be represented as both. So that's my first topic, is you can read them either way. There is no universal greater than. Typically we, though, as English speakers, read left to right, which means typically this is referred to as a less than symbol. Typically this is referred to as a greater than symbol. So you're not wrong. Typically this is greater than, typically this is greater than or equal to. But they don't really have an assigned name. Kind of like I said, hey bro, or hey sis to one of my friends. That's not actually their name, but it's often what we call them and often how they respond. That's typically a less than, but is it a less than symbol? No, it's just typically how it's read, left to right. But with the 6 to 8, let's start playing around a little bit with this. So with 6 is less than 8, let's pick a number and add it to both of them. Let's add 3. Okay, so if I add 3, I have a 9 and an 11. Now which one's greater? The 11. So what we're looking at is we're looking at the symbol did not change. The inequality symbol is still opening to the right. Let's try something else. Let's pick that same 6 and that same 8. 6 is still less than 8. Let's subtract something. Let's subtract 2. Okay? That gives me a 4 and that gives me a 6. Which one's greater than? The 6. The inequality symbol has not changed. Let's pick that same 6 and that same 8. 8 is still greater than 6. Let's multiply by something. Let's pick 5. So I'm going to multiply both of them by 5. 6 times 5 is 30. 8 times 5 is 40. Which one's greater? Well, the 40. So the inequality still hasn't changed direction. It's still opening to the right. Let's try division. Let's take that same 6 and that same 8. 6 is still less than 8, and let's divide them. Let's divide both of these by 2. Okay? So 6 divided by 2 is 3. 8 divided by 2 is 4. Which one's greater? 4 is still greater than 3. So in any one of these examples, did the inequality symbol change direction? No. So we can confidently say, that no matter what operation we're performing on an inequality, the symbol, the inequality sign, does not change direction, Pretty confident about saying that, Yeah, so let's go ahead and write that and see how it works out. Okay, so the inequality symbol opens in the same direction for every operation. Okay. So the inequality symbol opens in the same direction for every operation. Pretty good about that. We tried out 4 different operations. Everything's fine. Okay. Well, let's take that same 6 and that same 8 one more time. So let's take the 6 and the 8. 8 is still greater than 6. Let's try something. Let's multiply by, let's say, a -3. So if I multiply by a -3, okay, that 6 turns into a -18. and that 8 turns into a negative 24. Which one's greater? Ooh, the 18 is now greater. What we noticed is that the sign flipped. Okay, now let's take that same 6 and that same 8. 6 is still less than 8, and let's divide by something. Let's divide by a negative 2. 6 divided by negative 2 is negative 3. 8 divided by negative 2 is negative 4. Which one's greater? The negative 3. Okay, so with that, it flipped again. Okay, so then I asked, I'm like, okay, what's different from these 2 operations versus these 4 operations? We just said it opens in the same direction for every operation. What is unique to these 2? The negative. So we notice that when we multiply or divide by a negative number, it changes how we orient the final result. So that's going to add a caveat to our opening statement right here. So we're going to say, except when multiplying or dividing by a negative, and we flip it. Boom. So let's add that in there. Now everything's covered. Now that is the one and only thing that's going to change about inequalities, is we're going to work them exactly the same as we work equations, but we're going to have to pay attention to that flippage. And it may sound strange, but you've been doing this all along with equations, you just never realized it. So for example, if I take an equation, let's say I have an equation like this. There's my equal sign. Let's flip it. There's the flipped equal sign. What's different about that equal sign other than it's in red? Nothing, because it's equal. So unless I give it something to say, hey, I drew my lines this way, and then I drew my lines this way, you wouldn't even know that there was any difference other than the color, just so I can show you that that is a second equal sign. So equal signs also do flip. The good and the bad thing is, we don't notice it, so we've never really paid attention to that. So let's move on with some examples of what we're going to be doing in the first section. So we said that there are multiple solutions that are part of a set or on a number line. So let's go ahead and we're going to try testing out some solutions. So for number 1, we have a solution set right there. And now the number one thing that I get is I get, Mr. Johnson, I don't know how to draw that squiggly thing. So let's go ahead and figure out how to draw that little squiggly thing. That little squiggly thing is a bracket. You've seen brackets like this. These are called parentheses. You've seen brackets like this. These are called square brackets because we're creative. You've seen brackets like this, and these are absolute value brackets. That was the end of chapter 1. This is a new type of bracket. Whoop, 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 whoop. And this is where we have a solution set. Typically, these are used to show, hey, there's more than one answer, or there's a caveat to the answer where there's multiple iterations or some sort of pattern with it. How do we draw that? Well, I'll bring it to you. To draw this one, it is left, down, left, right, down, right. To draw this one, it is, do it in reverse. Right, down, left, left. That's it. Left, down, left, right, right. Or in reverse. So now you're a pro at drawing that little squiggly thing, as students like to describe it, which is just part of the solution set brackets. Okay, so we're going to test the solutions right here, but we're going to test them in 2 different inequalities. The first inequality is x plus 8 is less than negative 3. So A is x plus 8 is less than negative 3. The second one is negative 4.5x. Negative 4.5x is greater than negative 21. Okay, so what does it mean to test out a solution set? It just means plug it in and see if the equation, or see if the inequality is true. That's all we're gonna do. So I'm gonna take the negative 10 and plug it in for x. So negative 10 plus 8 is less than negative 3. Negative 10 plus 8 is negative 2. And I'm gonna ask, is negative 2 less than negative 3? No, this is false. Okay? So is that part of the solution set? No. Okay. I'm going to try the next one. Negative 4 plus 8 is less than negative 3. Negative 4 plus 8 is 4. And the answer is, again, false. I'm going to try the negative 30. So negative 30 plus 8 is less than negative 3. Negative 30 plus 8 is negative 22. Here's my first one. I got a true response. So I'm going to do this in green. Let's see how this works. So I have a true. This is a new green, so I got to warm it up a little bit. Again, sorry, there's going to be noises in the background. So true. So part of my solution set is that x equals negative 30. There we go. Okay. And then the last one, I'm going to plug in the 5. I'm going to say 5 plus 8 is less than negative 3. Here I get 5 plus 8 is going to give me 13. Okay. Is 13 less than negative 3? No, it's not. So I have false. Hopefully you can hear me over that, but it works. So again, we noticed that, hey, testing out a solution set's super easy. That's the only one that works was my negative 30. All three of these proved not a valid solution. So either they're erroneous solutions or something happened where we're just not going to apply those. Let's try the same thing over here. Again, all we're doing is we're plugging in values. So I'm going to say, hey, negative 4.5 times negative 10 is greater than negative 21. Okay. When I multiply by a 10, all I do is I move the decimal by one spot, so that's going to be a 45. So I've got a, let's see, negative negative makes a positive, 45. Pause. Am I multiplying by a negative? Is it going to cause me to flip my sign? Be careful. Am I multiplying both sides by a negative? No, I'm just simplifying. So I'm not actually using the multiplication property of equality. I am simply simplifying one side of an inequality. That does not cause the sign to flip, so I leave it in its regular direction. Is 45 greater than negative 21? Yes, so I have part of my answer is x can equal negative 10. Awesome, so we're off to a good start. Let's go ahead and try the next one. So I have negative 4.5 times, in this case, negative 4 is greater than negative 21. Now, if you don't have a calculator, you can't solve this one. So let's go ahead and pull out the other calculator you have. It's your hand, okay? So let's go ahead and do that. I'm gonna say that is 4.5 times 4. I'm gonna stack it and do this sort of multiplication method. 4 by 5 gives me 20. Carry the 2. 4 by 4 gives me 16. Plus that 2 is 18. I have one decimal in the problem, which means I have one decimal in my answer. So that's going to be 18. Negative negative makes a positive 18 is greater than negative 21. Double check. Do I need to flip the sign? No, because it's just one side of the inequality. Is 18 greater than negative 21? Yes. So I have a second value that I can plug in. X equals negative 4. Let's do the next one. Negative 4.5 times, in this case, we're doing negative 30. Which is greater than negative 21. Now I knew what 10 was. 10 was 45. This is 3 of those, so I don't need to come over here and stack anything. I'm just going to say, okay, this is going to be positive 135 is greater than negative 21. Is that true? Yes. So I have a third part of my answer. X is equal to negative 30 as well. So I've got 3 parts. Let's try the fourth. So I have, I'm plugging in a 5. So I have, I need these 2 colors. So I have negative 4.5 times a positive 5 is going to be greater than negative 21. When I simplify that, this is going to be, well, I know what 10 is. 10 is 45. 5 is half that. So this is going to be 22.5. It's going to be a negative greater than negative 21. In this case, I'm going to run into a no. This does not work. So as far as my solution set, I had one validation and I had 3 validations, but neither one of them had all 4 completely validated. So none of this is really hard when we cover this for any students. You might need to remember, like, how do I do this without a calculator? But overall, it's plug and chug. We know how to do this. We've done it hundreds of times. But is there a way to speed things up? And let's go ahead and see. So I'm going to pause the video real quick. I'm going to erase the board. Actually, no, I'm not going to erase the board. I'll erase it over here. And we'll just move over to this side. So when we get through this, one of the things that I talk about is I talk about why are we learning another method to deal with these when this method is so simple and so easy? Well, because throughout high school and as you start moving into adult life, ow, that really hurt. As you start moving into adult life, you'll notice that a lot of the tests all of a sudden start having timers put on them. Hey, I have 2 hours to take this test. I have 3 hours to take this one. I have 45 minutes to take this test. Because one of the things that you'll find out in adult life is there are things called an hourly wage, which means that you get paid by the hour. So what we're trying to get you guys ready for is we slowly start introducing timed events. Hey, you only have so much time to take this because your boss is going to want to pay their employees, get used to this, as little as possible. If the boss has 2 employees, one that does a task in 3 hours and one that does the task in 1 hour, he's going to want the 1 hour one because he has to pay them less, which means that employee has more job security. They're going to get hired even though they're only working for 1 hour. They get it better off. So we're trying to get you used to the fact that you want to start doing this stuff in a certain amount of time. Now, we realize that some students have extended time accommodations. And the idea is we can use those accommodations, but we want you to slowly start trying to wean yourself off of them so that you can get used to basically how adults are going to treat you. They're going to say, okay, cool, you need extra time to do this. I may or may not hire you. So while you're in school, use the extended time accommodations if you have them, but you want to get ready because your boss may or may not care that you had extended time in high school. He's like, hey, yo, you got 5 minutes to clean up aisle 5 because there's a giant mess over there. Otherwise, we might need to have a talk. So let's take a look at the other one. So what did we say? We said plugging in answers is easy, but it took a lot of time. That's what everybody says. Okay, so we want to try and prove every answer right off the bat. Okay, so we want to try and prove every answer immediately. So let's take those same 2 inequalities and see if we can't reduce our workload a little bit more. So for 2a, I have an x plus 8 is less than negative 3. And for b, I have a negative 4.5x is greater than negative 21. So how do I speed things up? I solve it like I would solve an equation. So I'm going to take this and I'm going to say, remember, when we're solving an equation, our first step is to simplify each side. How do we do that? When we simplify, we follow PEMDAS. After we've simplified, what do? We follow PEMDAS again, but we do it backwards. This is how we isolate a variable. So our first step is simplify both sides. Second side is to isolate a variable. We remove things in reverse order. Again, I know there's other ways out there. This is a general way to cover things. This way, I'm consistently giving the students a singular approach. So Both sides are simplified. I'm going to follow reverse PEMDAS. I'm going to get rid of addition and subtraction first, which means I get rid of the 8 by subtracting it. That cancels out. And I have x is less than negative 11. How long did that take? Well, it took like 1, 2, 3, 4, 5 strokes of the pen, and you're done. Now we can verify every one of our answers over here and whether or not we got it right. So x must be less than negative 11. Is negative 10 less than negative 11? No, it's going to end up false. Is negative 4 less than negative 11? No, it's going to end up false. Is negative 30 less than negative 11? Yes, it's going to end up true. Is 5 less than negative 11? No, it's going to end up false. So we just verified all of this with, like I said, 5 strokes of the pen. Done. So again, you're doing things a little faster, so you're getting more job security and you're getting things done. You can move on to those other questions and spend more time on the harder ones. So I don't want to do all these, especially because I had 3 of these be true. I want to be able to quickly spot them. How do I do it? I solve it like I would solve any equation. I check to see, can I simplify on either side? Nope. So now I'll move on to inverting it by following reverse PEMDAS. There's nothing to add or subtract over here, but there is a division multiplication step. I see that there's a multiplication right there, so I'm going to go ahead and divide by negative 4.5. Negative 4.5. Okay? So what ends up happening here is I get x is greater than negative, negative makes a positive, and I have to work with this. 21 divided by 4.5. Now I don't want to work with this, so I'm going to move the decimal over one place by multiplying the top and the bottom by 10. And then all I have to do is reduce it. So 210 over 45, they both divide by 5 is usually what students notice first. So that gives me a 42 over 9. The next thing they do is we divide them by 3 is usually what they notice. So I'll get a 14 over 3. So my x is greater than 14 thirds, or because I'm allowed to have a decimal, let's say you plugged into the calculator, that's going to be x is greater than, that is 4.6 repeating, so it's either 4.67 if you're rounding, or just 4.6 repeating. Those are my 2 possible answers. Feel pretty good about that, right? Pause. What did we just do here? We divided by a negative. So what do we do when we divide by a negative? We change the direction of the sign. So this was how we solved any equation. The one thing we have to pay attention to in chapter 2 is, does this happen? Okay? The only difference is it opened to the left. Now we're going to open it to the right. So we have a flip. So I'm going to open my answer to the right. Does anything change about the math? No, nothing changes about the math, just the direction of the sign. Okay? So when I look at x is less than 4.6, I go through here and I say, is negative 10 less than 4.6? Yes, it's going to be true. I don't need to do anything. Is negative 4 less than 4.6? Yes, it's going to be true. Is negative 30 less than 4.6? Yes, it's going to be true. Is 5 less than 4.6? No, it's going to be false. So we immediately prove everything, even if I give you more lists and I say prove all these extra numbers. You're just comparing 2 numbers as opposed to having to plug and solve. These were both one step as well, so it wasn't too overly ambitious, but if I gave you something where there was an entire equation over here, you want to do this method. So let's go ahead and let's practice a little bit more. Okay. So we've got 3 more problems that I want to make sure we're comfortable working before we jump on into the last little tidbit. So number 3 is n plus 7 plus n is greater than 15. Number 4 is going to be negative 6. 1 plus 2r is less than 90. And I guess I'll put number 5 up here. Number 5 is 24 minus 3n is greater than or equal to negative 6, 7n minus 4. Okay, so let's work out these questions. Again, I don't want to plug and chug too many answers, so let's go ahead and write our general rule here. We tend to follow PEMDAS in the beginning, and once we've isolated the variable, we follow PEMDAS again, but in reverse. So step one, step two. Okay. So step one over here, I'm going to treat this like I would treat an equation, and I'm going to combine like terms over here. I have an n and an n. That makes 2n plus 7 is greater than 15. Is everything simplified? Yes. So now that it's simplified, I'm going to start moving things away from the variable in reverse PEMDAS. So first thing in reverse PEMDAS is added or subtracted terms. So I'm going to subtract a 7, subtract a 7. That's going to give me a 2n is greater than 8. Now that I've got rid of the addition and subtraction, I'm going to move on to the multiplication and division. So I've got a times 2. I'm going to go ahead and divide by 2, which leaves me with an n is greater than 4. Boom. So in 1, 2, 3 steps, I solved every possible solution for that inequality. Notice, nothing was different than solving an equation. Those are all identical steps. If I look at number 4, let's try this one out. Again, I'm going to solve it just like I would solve an equation. The steps are identical. So I'm going to follow PEMDAS in the beginning. So PEMDAS says over here, I'm going to go ahead, I'm going to do the distribution step where I multiply everything in here by a -6. So I get -6 times 1 is -6, and -6 times 2 is -12. Now pause, I multiplied by a -6. Do I need to flip the sign? Again, students tend to say yes immediately, but I point out again, are we multiplying both sides by negative, or am I just simplifying one of the sides? Because if I'm just simplifying, I'm not actually multiplying both sides, it doesn't trigger the rule. So the final answer is no, we don't actually flip the sign here. We will here in a moment though. So now that I've simplified everything, I'm going to start undoing things on the side of the variable in reverse PEMDAS order. So that -6 needs to go away by being added. Oop, now I have a -12r is less than 96. And now that I get rid of the add subtract step, I move on to divide multiply, which means I'm going to divide both sides by a -12. That's going to give me r is less than -8. Pause. What did we just do here? We divided both sides by a negative number. So what that means is that the inequality no longer opens to the right, it now opens to the left. We get a flip right there. Okay. So again, everything solved just like we've solved equations for an entire chapter. That's the only new thing. So try this one out for just a minute. If you want to pause the video and give it a shot, do that. So now, assuming that you've had a chance to pause it, let's go ahead and solve it. The two things that I need to do is, one, I need to simplify both sides according to PEMDAS. That is simplified. This, I need to go ahead and distribute the -6 to everything in here. Now again, I'm multiplying by a negative, but only on one side, so I don't need to flip the sign. During this step, there is no sign flippage. It's only in this step. So I'm going to say -6 times 7 is -42n, and that's going to be plus 24. So I don't flip the sign. Now the next part that I ask students is I'm like, hey, I have split terms. I have a -3n and a -42n. And I ask them, which way do you want to move the n? Do you want to get rid of the -42 or the -3n? Normally we say, get rid of the -42n because it's the farther to the left of the number line. Why do I always say that? Because that will give us a positive coefficient, and you know what? I don't need to worry about the flip steps. However, every single class today has said, move the -3n. So you know what we're about to do? Move the -3n. It's going to give us a little bit more of a headache, but that's what every single class said to do. So let's go ahead and try that out. So if I add 3n, that cancels out that term, and I now have 24 is greater than -39n plus 24. Okay. Now that my terms are no longer split, they're in one spot, I'm going to go ahead and make sure that I follow reverse PEMDAS to get rid of everything off that side of the inequality. So addition, subtraction terms first, and here's where the second weird thing happens, is students know that those cancel out. And they're like, okay, I have -39n, but because there's nothing there, for some reason, students will all of a sudden like slap up a 0, or slap up a 1, or slap up an n. First off, where did that equal sign come from? I don't know why they pop up, but it happens all the time. Second off, where'd that n come from? You know, I can kind of understand the 0, but that sign has now moved. Remember, I always draw the line to remind ourselves something has to go here. So that means that, okay, I'm going to assume that, which means I don't need to write anything over here, and 24 minus 24 is, in fact, 0. So just keep an eye on that. Make sure that nothing moves all of a sudden. Now the last step, I got rid of that. Now I move on to this. I'm going to divide by negative 39. And what is 0 divided by anything? 0. Catch. We're dividing both sides by a negative number. So this inequality is now going to change directions. So I have a flip that pops up right there. But again, we notice that nothing is different about any of this. It is exactly like we've been working with equations. The last thing that we're going to do before we finally break is we're going to graph a few things on a number line, and we're going to see how that plays out. Okay. So we're going to graph the inequalities. We have 6, which is y is less than or equal to negative 3. 7, 5 halves is less than x. We have 8, z is greater than 0. 9, we have 11.2 is less than or equal to t. Okay. Now, when we graph inequalities with one variable, the number one thing that we're going to be doing is we're going to be graphing them on a number line. So let's go ahead and draw a couple number lines for each question. Now, the other thing is I ask students, I'm like, okay, what goes in the center of the number line? Almost 100% of them say 0, because 0 is the origin. Now, as we graph bigger and bigger numbers and more data sets, we always want to focus on the most important parts of those data sets. And where is the most important part of any data set that I've given you? The number in question. So what I'm going to do is at the center, I'm going to put each one of these. So negative 3, pause. What is 5 over 2? Well, I know that 5 over 2, let's do this in green actually. So 5 over 2 is equal to 2.5 or 2.5. So if you want to turn that into a mixed number, it's 2.5. So because that's not a whole number, what I'm going to do is I'm going to say, hey, between 2 and 3, that's where my number is going to be. This one is going to be at 0, and this one again is going to be between two numbers. It's going to be between 11 and 12. So every one of these, I'm going to go ahead and I'm going to say, hey, I'm going to draw a circle at my point of interest, wherever the number is going to be. Now when I draw off a little bit to the side. Next thing I'm going to do is I'm going to give some numbers on both sides, like a negative 2 and a negative 1, negative 4 and negative 5. Every single one of these, I'm going to give some numbers on both sides. And now the easy part, I just test to see what actually works out. So on the first one, I want numbers that are less than or equal to negative 3. So I'm going to try things. Is negative 4 less than or equal to negative 3? Yes, so I'm going to include that as part of my answer set. I'm going to shade it in. Is negative 5 less than or equal to negative 3? Yes, so I'm going to shade it in. Are other numbers over here going to be less than or equal to negative 3, like negative 6, negative 7, negative 8? The answer is yes every single time. So I'm going to thicken up the arrow that says, hey, all those numbers over there also fit. And then I'm just going to go ahead and shade everything in between them. Let's try the other side. Is negative 2 less than or equal to negative 3? No. What about negative 1? No. So I'm not going to shade in over there. But what about negative 3? Is negative 3 less than or equal to negative 3? And the answer is yes, so I go ahead and I shade in my number that's at the center of that number line. I'm going to do the same right here. I'm going to try everything out. Is 2 greater than 2.5? No. What about 1? No. Is 3? Yes, so I'm going to shade that in. Is 4? Yes. What about 5, 6, 7, 8, 11, 50, 100? Yeah, everything on this side of the number line is part of that answer set. So I know everything over here is all going to be part of my answer set. The last thing I check is the number itself, plug it in, is 2.5 bigger than 2.5? No, so I leave it open. I don't actually shade it in. That's where my line stops. It's not part of it like this one is. It's not part of it. For this one, I have z is greater than 0. So I'm going to go ahead and try out the numbers. Is negative 1 greater than 0? No. What about negative 2? No. 1? Yes, it is. Is 2? Yeah. Also 3, 4, 100, 1,000,000. All of these over here. So I'm going to shade all that in. And then I'm going to try out, is 0 greater than 0? No. I leave it open. The line stops right there and doesn't include that point. Lastly, the 11.2. Is 11 greater than or equal to 11.2? No. What about 10? Also no. But 12 is, 13 is, and all the numbers over here also are greater than 11.2. So I'm going to shade this side in and only this side. And last but not least, I check, is 11.2 greater than or equal to 11.2? Yes. Okay, so we have a rule based off of this. And this is our last and final rule. We have these two signs are always open circles because they're not part of the set. And then these two lines are closed circles because I know that that is going to be part of my solution set because of that or equal to included. I can include the number that I've got circled up. So that's it for this section. Let's go ahead and let me write down what the homework is going to be. So the homework for this section is going to be on page 56. We are doing numbers 1 through 18 odd. And that's going to be due on 9/18. That's going to be due tomorrow. Now, I told every class that. I forgot I'm going to be out tomorrow. So tomorrow, you're going to have a Delta Math assignment when you come in. Make sure you watch that Delta Math, or make sure you do that Delta Math assignment. Also, for tomorrow's homework, we're going to keep it nice and simple. I'm going to make it, guess what? Page 56, numbers 1 through 18, even, and that's going to be due 9/19. Okay, so the day I'm going to be back on Friday, you're going to turn in both this and that. Now again, these problems, they're not meant to last a long time. You're just going to be writing down a few of these things, and I believe you're going to be testing out some of the solutions, like some of the things we did right here earlier on. So until then, have a good day tomorrow. Make sure we do the Delta Math assignments when you get into class, and I'll see you on Friday.